Some friends from Callaway talking about how club design affects fitting and instruction. A lot of you know this gentleman here, Randy Peterson. Coming up this year, he'll become a 25-year member of the PGA of America. A lot of us remember him when he used to beat our brains out on the golf course. Heck of a player. Went to work for Callaway. He is now the director of club fitting for Callaway Golf. He works with a lot of the tour players. Obviously, he works with a lot of amateurs. Knows a tremendous amount about the golf swing, about equipment, about the science of both of those things. So we're very, very pleased to have Randy with us. He's played in tour events. He's dominated a section level. Really, really anxious and thankful that we have Randy here. With Randy is Nick Arthur, who is one of the lead instructors at the Ely Callaway Golf Center down in Carlsbad. So without further ado, I'll turn it over to Randy.
Thanks for having us today. We're excited to be here. As Bill said, both Nick and I work at Callaway. We work in the R&D department. We work at our test center where we fit club pros, elite players, college players, and amateurs. And we've worked with, literally we've worked with hundreds of pros in our time.
Turned on, sir?
Oh. Got batteries. So literally Nick and I have both worked.
Go ahead, you should try it out.
We've worked with hundreds of pros in our time at Callaway. And what we'd like to do this morning is just share some of the information that we've found successful and useful and beneficial to us. Is it okay, Brian? Beneficial to us during our time at Callaway. So let's get started. What we're going to talk about first is we're going to just lay down some foundational definitions, a little bit of club design, features, interactions, measurement systems, what's measured, what's inferred, and then a couple closing comments. So it may be a funny story real quick just to start with. It made me think about it when Brian mentioned Johnny Miller and how great a ball striker Johnny Miller is. I've worked with Johnny Miller several times at the test center. And Johnny's not afraid to let you know that he's a great ball striker, and he's a phenomenal ball striker. But one day the fidelity of our measurement system is incredible. And we were doing a shoot for Golf Magazine. And so Johnny was there, we're in the fit bay, everything's all hooked up. And he's hitting 5-irons, and they're gonna take some video of his swing, and then they're taking images of the monitor. And so he's warmed up a little bit. The guy from Golf Magazine says, "You ready to go?" Ready to go. Hits a 5-iron. All the numbers start to populate on the screen. So path, attack, head speed, ball numbers come up, launch angle, spin, side angle, backspin. So in side angle, it's 0. And I know Brian said, you can get a 0. On our systems, it's almost impossible to get a 0s. Even when you hook a robot up, it's impossible to get 0s. So anyway, the numbers are up. Side angle says 0, side spin says 0. So the guy from Golf Digest, he's looking at the images and he says, "Johnny, can you hit another one? I think we missed that one." And he said, "No, it got it." I mean, he knows that ball was absolutely dead straight. And that's just, we would put him he would come in and test irons for us. And regardless of the iron, the model, the shaft, they all went straight. And drivers, I mean, incredible ball striker. Through the bag, probably, if not the best ball striker through the bag, certainly one of the top 2 or 3. All right, starting with definitions. We're going to start with moment of inertia. Moment of inertia is an object's resistance to twisting about a specified axis. So in golf, what a moment of inertia defines is the club's forgiveness. The higher the MOI, the less the club will twist on off-center hits. And that's significant because when the club's twisting, you're losing energy that could be transferred to the ball. So anytime you get any rotation about the head, you're losing energy, you're going to lose distance, and you're going to lose direction. So high MOI, more forgiving, low MOI, less forgiving. Just for general knowledge, as we hear now, as CGs are getting lower and more forward, the more forward a CG gets, the lower the MOI is. So it doesn't mean low forward CGs are bad, it just means that there's a lower MOI and your impact location better be pretty concentric. Center of gravity. I think everybody knows what center of gravity is. You call it the balance point. The technical definition is the point where all the weight of an object can be considered to be concentrated. So we have 3 different angles here of a driver head. Adjustable CGs now are super popular. You see them all over. We've got 2 ourselves. This is the big Bertha where you can adjust the weight around the perimeter. If you look at the image here, you can look at the bottom. If I'm moving this weight heel to toe, I'm going to move that CG heel to toe. So when I'm moving the weight laterally, this is going to be used to affect shot shape. So if you want the ball, if you want more fade, less hook, you're going to go to the toe, opposite for the heel. If you're moving the CG, this is our Big Bertha driver. Our Big Bertha Alpha has a vertical CG adjustment. So there's a gravity core in it. I'm going to leave this up here if anybody wants to look at it later. The engineering is really cool. So it's got a core in it. You can turn the core up or down. That moves the CG vertically. So that's used to influence ball speed, backspin, and launch angle. The majority is backspin. So. And we're going to talk a little bit more as we go about deeper and low forward and what's robust and what's not robust. Yes?
Brian, in this thing, talked about moving CG. I don't remember, he said he mentioned talking with glue and so forth. How much actual movement in real time does that CG move when you move?
And the increments are small, the magnitude can be great. So you can move the CG 100 thousandths of an inch and it can make 300 or 400 RPMs of difference in spin. So it's, I mean, like in this, it shows the CG at the geometric center of the face. The increments are so small, it's almost hard to wrap your head around it. But when you hear like low forward CG drivers now, there is no driver made where the center of gravity is below the geometric center of the face. So when they talk low forward, it's low forward relative to another driver. But there is 0 drivers made on the market where the center of gravity is below the geometric center of the face. Every driver made, the CG is above the geometric center of the face. And the increments of movement to create spin are so small, it's hard to even say the number. But like when we work with Phil, we'll move 10 thousandths of an inch in his driver, and it makes a significant difference. And for some players, it makes a bigger difference than others, and we'll go into that a little bit too.
Let me add something.
Yeah.
I would say too, when you talk about thousands of inches and you're talking to your students, that's hard to conceptualize for guys. So can you hear, is this, hello, is this working? A dimple, right? A dimple on a golf ball, that's the kind of distance you're talking about. And it just takes a very little offset, and the club goes spinning and the ball goes spinning.
Yeah, that's what I would talk to a student about, the thousands of an inch, because I'm curious, because it used to be that, you'd hear people talk about, well, they're going to put a bunch of lead tape on it to move the CG, and I was always told, well, that you're not holding that CG well. So I was just curious how much that.
Put the entire roll on the toe and get some duct tape and wrap it around.
Put a lot on there.
And you'll
move it that far.
Yeah, you got to put a lot. Gear effect. So gear effect is what occurs when the center of gravity of the head and the center of gravity of the ball are misaligned. And Brian mentioned this earlier, but there's an offset there. And the greater the offset, lots of things start to happen. So the head rotates upwards. Obviously, this is a vertical gear effect where the center of gravity of the ball is above the center of gravity of the head at impact. So in this condition, the head would rotate upwards, launch angle goes up, backspin goes down. Now, depending on the MOI of the driver and how great that offset is, you can start to see launch angle variance of 6, 7, 8 degrees, backspin variance of a couple thousand. And the big thing is you can start to see ball speed drops of 7, 8 miles an hour. And that's really common. So when we're working with somebody, we use face tape all the time. Every time we work with a tour pro, anybody, we have face tape on the club. So we can identify where they're hitting. We also have measurement systems. But face tape's a cheaper way to do it, and it's easy for people to understand. A lot of people, you'd be surprised, even tour pros, a lot of them don't know where they hit the ball specifically on the face all the time. And it's gotten harder to know because these drivers, the MOI is so big, they feel good all over the face. So gear effect is critical to understand. What the first 3 things in moment of inertia and center of gravity and gear effect. When you're analyzing either a swing for instruction or a swing for fitting, it's critical to be able to read the ball flight. And if you can't read the MOI, the CG, or the gear effect, it's hard to read what's going on with the ball flight. So these things, that's why we put them up in front. They're very important to understand if you're going to read what's going on with the ball
I
flight.
got a quick question.
Yes, sir.
So if that center of gravity that's in that head,
Yes.
so that's assuming basically like a level hit, right?
Yes.
And you lose some energy because they're not lined up. If that center, if the hit was upward, that CG of the ball, the club, would be going closer to the CG of the ball, and that would be one reason you might get a little more distance because you get a little more energy?
Yeah, anytime you get those CGs headed toward each other, it's going to be a better energy transfer, right?
Right.
And when you get them going this way, now they're going to glance and spin off each other, and the energy transfer is almost high.
Yeah, so this would be delivered at a zero-out angle, yeah. So this is the opposite condition. So this is when the center of gravity of the ball hits below the center of gravity of the head. So in this condition, obviously the head would rotate down and the spin goes up, the launch goes down. Of the two, this is by far the most penal. So if you're working with somebody and they're hitting a little bit above the CG, that's not the worst thing that can happen. Hitting below the CG is the worst thing that can happen typically. And the reason is, when you hit below the CG, both launch and spin are working away from optimum. Launch is going down, spin is going up, and those conditions are both good if you hit the ball too far and you're trying to hit it shorter. If you're miss above the CG slightly. This is horizontal gear effect. So this is what's happening when the offset is toeward. So now you're hitting laterally on the club. One quick thing to mention, a driver has the MOI in the vertical plane this way is much lower than it is in the heel-toe plane. So if you get offset this way, you can get away with that a little bit. So if you're working with a player, say you use face tape and they're hitting it a little bit at heel-toe, there's not going to be as much dispersion or loss of energy transferred into the ball across the face as there is up and down the face. Paying attention to where you're hitting vertically is really, really critical. It's critical horizontally too, but it's not, you can get away with more because the MOI is greater in the heel-toe plane. So in this instance, you can see the CG offsets out towards the toe. What will happen is the toe will rotate open and the ball will leave with draw spin. How much that happens depends on a few things. How fast it's going, how big that CG offset is. One thing that happens with drivers that doesn't happen with an iron, and we'll get into this a little bit more, is with an iron, with a driver you have gear effect because you have what's called a transverse shear. So when you get an offset, say in this instance, you can imagine the ball's right here and the face is here. When you hit to the toeward or the heel side, the club actually moves laterally. So as that's happening, as that shear is happening, that's what's creating the gear effect. And you don't get that with an iron because the center of gravity is much closer to the face. So that shearing, that lateral motion helps absorb some of the impact. You don't lose as much ball speed as you would on an iron, and it creates that gear effect. Nick, do you want to talk about closure rate versus CG change? A lot of people are under the impression that when you move the weight around, you're changing the closure rate, and that's what's actually changing how the club comes into the ball. Brian talked about closure rate, and that's so if I put the weight in the heel, the club's going to close faster, and that's why people tend to draw more with the weight in the heel, versus actually moving the weight and creating more of an offset with the CG.
Yeah, I would say that I've never, we do a bunch of events where we bring our retail accounts in, all the salesmen are from all over the country, and we try to train them on how to more effectively sell these golf clubs and what the features and benefits are and what they really mean. And I don't know that I've ever gotten anyone that answered that question right, because I'll ask them, hey, when we move the heavy screw toward the toe and that creates what we call more fade bias or less draw bias, what is actually happening? And all of them think they know the answer, and usually they raise their hand and I go, and I pick one of them and they'll say, well, obviously if you put more weight on the toe, it slows the toe down. So they're talking about closure rate. There might be some of that happening with an iron. I mean, anecdotally we see, we go to the short blade, maybe there's more closure rate on the face coming to impact based on the torque he's putting on it, maybe he hooks it more. But with these oversized high MOI drivers, it's really not closure rate as much as you're just taking the CG of the driver and you're moving it out of line of the golf ball. So if you want to create more draw, yes, you're creating more of a toe hit, but for a slicer, if you pick up 300 RPMs of draw spin and you lose a half mile an hour of ball speed, that's a good trade. And I even talked to Brian a little bit of this when he was visiting on Friday. Every now and then you get the guy that hits the heel slice, where you move the weight into the heel, that moves the sweet spot. He's getting more ball speed and he's actually increasing draw spin or reducing fade spin.
And we've got a left-handed guy that does that, Phil Mickelson. We take his drivers and we move the weight way into the heel. He hits his drivers high in the heel. All his impact locations are high in the heel with his driver. So we take the weight and we shift it high into the heel, and it mitigates his fade, and it gives him a lot more ball speed. And a corollary to that, or the opposite of that, would be Jim Furyk. When we work with Jim Furyk on drivers, he'll find the CG. So if you give Jim Furyk 3 or 4 swings, you will move the CG around the face. After 3 or 4 swings, his impact location will migrate to where the CG is. So it's a little bit harder to fit him. laterally on the CG because they don't have as much effect. We're not creating any offset because wherever the CG is, he starts hitting the ball there. And he's unique that way. And he hits the ball phenomenally well, unbelievably straight, and a good guy on top of it. Bulge and roll, real quick. So bulge is the horizontal curvature, roll is the vertical curvature. Bulge is on the face to start the ball offline. Some people are under the impression that you put bulge on the club face so that this curvature, when you hit it on the toe, is what actually gives it the gear effect. The curvature doesn't give it the gear effect. The bulge actually is on the face to compensate for the gear effect to make the ball go offline. So if this face were flat and I had a CG offset, the ball would start at the target and it would curve to the left of the target. So you flare the toe, you open the toe, so the toe is actually pointing right at the geometric center, so the ball starts offline and then curves back. And how much bulge you put on this, Brian touched on this a little bit with bulge earlier, how much bulge you put on this to offset gear effect is a tricky equation, and the tightness of this bulge can change based on the MOI of the driver, will change based on the MOI of the driver, and also the CG location of the driver. And roll is just the opposite. Roll is the vertical curvature. So if you're hitting high on the head, you don't want the ball, you don't want the face flat, you don't want the ball to launch low. The higher you hit it, you're going to lose spin. So you need the ball to launch up in the air higher so you can still maintain some kind of distance.
So more MOI, less bulge.
Yes, exactly right. And you can get an idea now, just look at it. If you go out in the market and you look at drivers, you see smaller headed drivers and the face is really curved. That's what we call tightness on the bulge. The tighter that bulge, the more curvature is, the lower the MOI that driver's going to have. So if a driver's got low MOI, you need more bulge because you're going to have a greater gear effect. The ball's going to curve more. You need to start farther offline. So if you're looking at a driver and you see a lot of curvature on the face, you can pretty much assume they either misdesigned the club horribly or it's got a low MOI. One of those two things. Loft, everybody knows what that is. It's just on here for the magnitude. It's the angle of the club face relative to horizontal. Well, again, because the face is curved, loft can change radically over the face. So the loft is measured at the geometric center of the face, but at the top of the club, it can be 4 degrees more, and at the bottom of the club, it can be 4 degrees less. So if it's 9 degrees in the center, you can have 13 degrees of loft at the top of the club and 5 degrees at the bottom of the club. So again, by using face stick, you see the magnitude that's possible of impact locations, how much launch angle you can get, how much spin you can get, change on impact location based on where you're hitting it on the face. And also always keep in mind, vertically, the MOI is lower. Now, if I held the impact location constant, say I constrain the impact location, change in loft by 1 degree will change spin by 300 RPMs and launch by about 8/10. It's not a 1-to-1 ratio. So obviously if I go from 9 to 10 and the impact location is the same, I'm going to increase backspin by 300 RPMs and increase launch by about 8 degrees. Or 8/10 of a degree. So there's obviously the change in impact location, the magnitude is much greater, the potential is much greater than just changing loft. And like with all specs, there is no industry standard. So because a club says 9.5 on it, it could have 9 degrees of loft, it could have 13 degrees of loft. There's nobody saying what it has to be. So if you're teaching somebody or fitting them and you're working with different manufacturers' drivers, it helps to know how that manufacturer designs, what they tend to design to. Some design their drivers really weak, some design them pretty close to stated loft. And looking at them, you can get an idea. If you have somebody, a workshop around that can measure them, you can do that. And a lot of times the reps know too, and they can help you out with that.
So if you guys say 9.5, what is it?
On our driver, depends on the driver, but most of them are slightly weaker than what they're stated. So they typically, a 9.5 for us is typically between 10 and 10.5. And so we have competitor drivers at 9.5, they're at 13. So.
Are you looking for the exact number? Are you always referencing it to the center line of the shaft? Or a projection of the center line of the shaft?
We're looking for the loft.
Question that he asked, what is it? You said it's a little less.
Can you repeat the question?
I didn't understand.
I think he's saying what's the reference frame we use for loft.
I'm sorry. The question is, when you state a number,
Yes,
you're obviously measuring at the center of the face where you want to hit it.
center of the face
And it's
square
the
and
angle
geometric.
from that face to something else. Is the something else the shaft center?
Yeah, it's
Yes.
gonna be. It's not gonna be the sole. In other words, that the reference frame is gonna be the shaft center line.
Yes.
And is that standard across the industry?
No. There aren't any standards across the industry. There's no ruling body that says you have to report this, you have to measure in this condition and report in this condition on specs.
So the fact that that shaft is leaning back in that picture is just an accident.
Yeah.
Yeah.
Yes.
Static face angle, so this confuses people a little bit. So this is the face angle with the club closed, measured at the geometric center. And when I open the face, it makes the club play stronger, it takes loft off. If I close the face, it adds loft. And changing the face, again, it's not a 1-to-1 ratio, so opening the face a degree would change the loft about 7/10 of a degree. You can't decouple the loft and the face angle. So if I'm opening the face, I'm decreasing loft, I'm closing the face, I'm increasing loft, and those two always work in concert. It's not possible to decouple those two. And again, the face is curved. Brian mentioned earlier that a measurement of 5 degrees open on the toe. We measure, this is about a 10-degree bulge, and it's about 2 to 2.5 degrees on the toe, and about 2 to 2.5 degrees on the heel, in terms of how the face would flare. Iron. So, this is what we would call the distance. You can see the red line from the hosel center out to the center of gravity. The center of gravities are a little bit they're a little bit exaggerated just for demonstration purposes, but this was what we would call the moment arm. So that distance, this distance from the center line to the center of gravity, the longer that is, the shorter that is, the lower the MOI. That's the moment arm. The longer it is, the higher the MOI. So on the left is a blade type iron. So a lot of people are under the impression that a blade type iron, you can rotate it easier. Pros like them better because they can work the ball better. It's easier to hold it open. It's easier to close it. The MOI is lower, so the resistance to twisting is less. That's absolutely true. So because a blade iron has a lower moment arm, it's much easier to control, much easier to rotate the face. A game improvement iron on the right has a longer moment arm. It doesn't rotate as easy, which seems a little bit contrary to design because most amateurs hit the ball with the face open. So why would you give them a club that's a little bit harder to rotate? The reason is because you can disperse the weight around the perimeter greater with a game improvement club and increase the MOI. It's more beneficial to them because their impact scatter is all over the face. They lose less ball speed, they lose less direction on off-center hits, even though you trade off slightly for not being able to rotate the club as much. On the left, you see a tour player has a very concentric impact location, so they don't need a super high MOI, but a game improvement iron needs that high MOI. That's also why we put offset on there. Nichols said a couple things about the irons.
Yeah, I would say from a fitting standpoint too, there's a general correlation between skill level and the kind of head model you're going to use. If a guy walks in, he's getting fit, and he's got a ball retriever hanging out of his bag, he's probably not a blade guy. But if you watch the way a guy delivers it and where he hits it on the face specifically, I had a guy the other day, he was probably a 10 or 12 handicapper, and he liked blades, he liked the way they looked, but didn't think he was good enough to play them. But every hit location was right into the neck. I mean, he actually shanked a couple when he got off a little bit. So when we put him on the machine, when we look at the speeds, he actually got very good speed off a blade because blades typically have more heelward center of gravities. Whereas
less offset, right? Again.
Exactly, less offset between where he's hitting it and where the center of gravity of the club is. So the ball speed was very good for him, and it felt very good, and it felt very good because his heel hit works pretty good with the blade. On the other hand, I've had scratch players come in that think they need to be using the blade, and they hit everything very consistently, but it's out low toward the toe, and they do not do well with the blade. Blades do not like that. So maybe more of a cast, longer, less offset pro type cast iron would give him a lot more ball speed. So there's not always a direct correlation. You want to look at each person on an individual basis when you fit them for head model.
Which is again why we always use face tape. So once you can determine where they're hitting it, you can start to back into where you need to go. Progressive CG, so we vary, and most companies do, in our blade type irons, we vary the height of our CG. And the reason is that for a good player, they want their short irons to be down and their long irons to be up. They actually want the peak of the ball to be about the same with every iron. So you vary the CG to help them accomplish that. And also because they're hitting down on the ball steeper, the geometry of the swing, they hit down on the ball steeper with a short iron than they are with a long iron, they tend to contact the short iron slightly higher on the club. With the game improvement iron, the center of gravity we put low on all of them because game improvement players tend to come at a much shallower angle. They don't have much shaft lean. They pick the ball more. They don't take much of a divot. So you want to get the center of gravity of the club down where they're going to impact the ball, where they can gain the most ball speed. So that's also why our game improvement irons and most everybody's game improvement irons have what you see with a real wide sole. That wide sole helps pull the CG much farther down the blade. Irons. Well, I know bulge and roll. We talked a little bit about this earlier. With an iron, when you hit the center of gravity of the iron is so much closer to the face because there's not depth to the club like there is on the driver. So when you hit to the side of the CG with an iron, it pivots more like a door. You don't have the shearing effect. There's no transverse shear like you get with a wood when you have the depth. So without that shearing effect, there's not a gear effect created. So in a technical sense, there is a slight gear effect with an iron depending on how deep you get the CG. If you add weight back, you can pull the CG slightly off the face back. But in a practical sense, it doesn't matter. It's not going to side spin. You'll see a side angle because the ball will pivot, but it doesn't create a side spin. So that's why you don't there's no bulge or roll on an iron. Lie angle. This is one that people have a lot of questions when Nick and I work with PGA, even PGA pros, and when we do seminars at the test center for guests. The reason that the ball curves when a lie angle is off is because the face plane is not parallel to the leading edge of the club. It's not that the toe digs in, opens the face. That may happen, but that's a corollary. Everybody's seen this. But what's really happening here is you've got compound angles. The face plane is at a different angle than the leading edge of the face. The more loft, the more disparate those angles are at. So if I take this and make it too flat, it's going to point to the right. If I take it and make it too upright, it's going to point to the left. As the loft decreases, that angle gets mitigated. So that's what's really making the ball fly offline. It's not that the toe's digging in or it's not that the heel's digging in. If I hit a club that's too flat, it's going to go to the right if I hit it off a robot, if I hit it off the tee, if I don't touch the ground. It's compound angles are what account for that.
If the face opens because the toe hit the ground before impact, you've got other problems to consider.
That's what you guys are for.
Yeah.
They need some lessons.
Not the leading edge, not the score lines, but the leading edge. What about the really round the leading edge?
No, I mean, the score line can be the bottom score line is a good reference for the face plane.
Change in length a half inch will change lie angle a degree. So obviously if you go upright, if you add a half inch in length, make the club a half inch longer, it's going to play a degree more upright, the opposite on the down direction. Lie angle has almost no influence on impact location. So again, a lot of people think, oh, I'm wearing out the toe, my club must be too flat. Lie angle doesn't have anything to do with where you're impacting the face.
Sorry, Randy?
Yes.
I guess drivers are built on about 60 degrees standard lie angle.
Yeah, close.
But when we hit them, they're about 46, 7, 8, somewhere in there. So there's like 12. Is it the droop that's purely accounting for? Or is it that the driver is conspiring to slice and toe up helps us not slice it? Or is it just pure droop?
A little bit of everything.
Yeah.
And with the off the rack models where you're going to look at a standard model with the CG is heelward, the face is a degree closed. Lie angle is another one of those tools we're using to try to take the guy that's a slicer and help him not slice as much. But when the pros come in, we're almost always flattening the lie angle in the drivers and opening the face and moving the CG toward the toe. So,
and the lie angle effect on the driver that we bend is you have to create a bigger angle to get a smaller gain. So if we're changing lie angle, sometimes it's 2 or 3 degrees on the driver just to try to have the difference. Lie angle, do you change it for ball flight or to get the divot to look like what you want it to? We do it. Since we signed Phil Mickelson, I've been his principal club guy. And when we first signed him at the end of 2004, he came out, the first time he came out with a set of irons. We made him a set of irons based off the specs that he had had with Titleist. And we went out, just him and I went out to the range. And he started with his log wedge, and we went through his 3-iron, and he hit balls with every club. And he'd start with his lob wedge and he'd say, I want to fall more left. And I'd go inside and bend it flatter. And he'd come back out and he'd say, more. And I'd say, I want to fall more left still. And I'd go bend it more flatter. And I would jot down, I had notes on everything that we were doing, but he didn't care. So we went from the lob wedge to the 3-iron like that. He didn't care what the divot looked like. He didn't care what the number was. All he was trying to do was produce a flight that he wanted to see. We did that from a lob wedge to a 3-iron. He didn't care if it was 7-iron, was more upright or flatter than his 3-iron, and he still does that today. His lie angles are all over the place. He doesn't care. So on the other hand, when Jim Furyk comes in, Jim Furyk will hit a ball and not look at the ball. He'll immediately look at the ground and start seeing if the toe's too deep. And they all go straight anyway, so you need to look at it. But he's, for the most part, the way we do it, unless the player directs us otherwise, we always adjust lie angle to produce the desired ball flight, not to produce a desired divot. Sole corresponds to the bounce of the club. So 5-iron has 5 degrees of bounce, 4-iron has 4 degrees, 7-iron has 7 degrees. That's a fairly standard thing. Sole width acts as bounce also. So if you have two 60-degree wedges and they both say 8 on them, but one has a wider sole, one with a wider sole is going to effectively play more bounce, with more bounce. And the reason is you have more interaction between the club and the turf. That's going to keep the club from digging. So, and where you place the bounce on the club can have a big effect on how the club plays. So when you move the bounce back on the club, it's actually easier to get the club the leading edge a little bit under the ball. It's easier to hit the ball a little bit higher. So if you move the bounce back, you can hit the ball higher. If you have a narrower sole, it's easier to get the club under the ball. You can hit it a little bit higher. So, and again, there's just like everything else, there's no industry standard when you talk about bounce. So some manufacturers put bounce on the club based on what they think the consumer wants to see. So there's a perception that bounce is bad, especially too much bounce. So people think, well, if you have bounce, you're not a good player, you're too steep, whatever. It's not uncommon for us when we work with tour pros from other companies that are looking at our company, where we measure the first thing we do when they come in is we spec their bags. So when a guy comes from another company, it's not uncommon that they have a 60-degree wedge that says 8 degrees of bounce on it. We'll measure it at 13 degrees of bounce. So they're not being disingenuous in a sense that you're measuring an arc. So nobody's telling you where you have to measure that arc. You can measure it anywhere you want and report that. But that happens all the time. So there are very few wedges that actually have 6 or 7 degrees of bounce. Very, very few. Grooves. This is a little bit of a busy plot, but if you just focus on, these are the two extremes, the 45 and the V. This 45 would be the kind of the copper brownish one, and the 5V, that's the angle of the wall, would be this one. And grooves are on the face, essentially, I think everybody knows, to give debris, water, dirt a place to go so that the ball can interact with the club face and create friction. That friction is what's helping produce spin. So the greater this volume of groove, the more room there is for debris to go, the more interaction I can get with the face and the ball. That's why grooves make a much bigger difference out of rough than they do out of the fairway. Out of the fairway, you got a clean lie, so you don't need a place for grass to grow. So the wider it is this way, the bigger the volume, the more aggressive the groove is. This 5V groove is actually the groove that we have in our Mac Daddy wedges. It is the most aggressive groove that we can use by USJ regulations. If you look at this top line, imagine that's the surface plane of the face. Where the groove meets that edge radius also has an effect on spin. So the sharper that is, the more spin you're going to have. And it is true that when you chrome a wedge, you're adding material back onto the wedge, and that dulls that surface radius. So a chrome wedge will spin less than a raw wedge or a vintage wedge. So if you're working with somebody who wants more spin, they should be using a vintage wedge. And if you have somebody, there's a lot of people that chip that say, I have too much spin, I'd like to get some of the spin off. A chrome wedge will help take some of the spin off. And face treatments, surface treatments in between the grooves on the actual face, the etchings, they do help with some spin. It's the same as the grooves. They're more effective out of rough than they are off the good lie. And they don't last very long. That's one thing that the USGA is big on, is spin. So those will be on there. They'll last for a little bit, but they wear pretty fast and don't last very long.
Eddie?
Yes?
Chrome versus raw, about how much difference is that?
There's several hundred RPMs of spin difference. I mean,
Wow,
it's
3?
yeah. Like Nick said, there's so many other factors. How fast it's going, the angle you're hitting. There's a bunch of other factors. Yeah, but it can be 300 or 400 RPMs of spin.
That'd be on the high end.
Yeah, it can make a difference.
I wouldn't look at that as an average. You're going to pick up 300 when you change the finish like that.
In the rough, it can be significant, but yeah. Measurement systems. So we've got our own measurement system. This is our measurement system down here, and there's a couple cameras in there, each take 10,000 images a second. So that's a camera-based system. The two main types of systems are a radar system and a camera system. So a radar system would be like a TrackMan that sends out a radio signal, and it hits a blob, it sees a blob, and it reports back. That system, the benefits of that system is it's less susceptible to light, it's easier to set up. If it goes cloudy on you, you don't have to worry about it. They're a very robust system. The drawback is they're really very good at measuring the ball, not quite as good at measuring the club head. Because the club head's very, very hard to measure. The club heads, not all club heads are the same shape, they're not all the same size, they're traveling at different speeds. The closure rates are different based on the player. So when you're sending a radio signal, you're hitting that head in one spot. But you're not identifying, is that the toe, is that the heel? What's the club, what's the shape of the club? So, not that it's not accurate, it's just a different type of measurement system. Regardless of the measurement system, the ball is always much easier to measure than the club head. Always. A camera system so with camera systems, you're actually taking an image of the head. So a camera system, the benefits are you can put markers on the head and you can identify a specific part of the head. So you can measure the hosel, you can measure the shaft, you can measure the toe, you can measure the face center when you're taking images of the club. So it's a much more, the fidelity of the system, the potential is greater for measuring the club head. The drawback is with camera systems, they're much harder to set up. You need markers on the club head, and they're definitely susceptible to light and conditions. So there's pluses and minuses to both of them. Obviously, reported values on both of them can vary significantly too. We'll just talk about some measurement data. So club head speed, obviously it's measured miles per hour. It can vary greatly depending on where it's being measured. So if you're using a laser system and that laser system is hitting the toe, and you have someone like Phil Mickelson who's got a super fast closure rate, that head speed is going to measure really fast. It's hitting more towards the heel, or the closure rate like somebody like Jim Furyk, the head speed is going to measure slower. So the measurements can vary significantly based on where it's being measured. The toe typically is moving around 10% faster than the heel because of the closure rate. So, and you can't accelerate, you hear this a lot. It might be a good teaching axiom to tell people to get them to speed up and swing through the ball and accelerate through the ball, but it's not possible. There's a collision taking place. So in order for the ball to speed up, to leave, energy has to be transferred from the head to the ball. That's what's taking place in this collision at impact. So the head loses about a third of its pre-impact speed at impact. So if it's going 100 miles an hour, it's going about 67 miles an hour after impact. Impact face angle. So again, this can be a little bit tricky depending on the system you're using. The face angle is super hard to measure. We have $100,000 machines that we can actually do this. We do it. One thing I was going to mention on head speed that I forgot, just anecdotally. The head speeds, as you know, have been trending up. And the average head speed for a male is about 95 miles an hour. The average PGA Tour head speed is somewhere in the 114, 115 now. About 3 years ago, for those of you, for our test center, we have a long range, and to the side of the range, we have a putting green. And Mickelson was out there one day, and he was hitting that flop shot that he hits. He's about 20 yards away, and the green's very shallow. And it's probably 12 feet in depth. And it's hard to hit a pitch shot, a 20-yard pitch shot, and keep the ball on the green, land it on the green, and keep it on the green. He was actually hitting the shots on the green and backing them up a little bit. So we went and got our measurement systems, and they take a while to set up. So we got them all set up. You got hit from the same place. Again, it's very hard to measure. So just to see what he was doing, we want to see what his attack angle was, where he's impacting the face, what his path is. And his head speed on a 20-yard shot was 95 miles an hour. So it's about 4 miles an hour faster than the average driver speed on the LPGA. So the point is you have to have some serious gonads to hit that shot in the tournament, because if you skull that shot at 95 miles an hour, it's going 150 yards. So It's crazy. He's so far across those shots and so far down on them. He impacts the head so much on the high toe that he puts so much spin on it and kills the speed because the CG offset is so great. It's amazing to watch. Anyway, Brian was talking closure rate earlier. So this would, on our robot, if we set a driver up, and again, it depends on the MOI of the club, if we set a driver up on our robot at 100 miles an hour, the closure rate's about 2,200 degrees per second. So, and you know, it varies, obviously, it varies depending on the player, it varies depending on the speed and the MOI of the club. Impact face angle, again, because the face isn't flat, the toe obviously is pointing to the right of where the geometric center is pointed, the heel is pointing to the left. When you get systems, when people are all in on a measurement system, and they say, okay, the face is at this angle to the path, you have to be careful that the system you're measuring can actually detect where the face is. And if it's back calculating where the face is, based on where the ball flight is, and it doesn't know the impact location or the MOI of the driver, then you got to be careful. So it doesn't mean that it's not right, it means that the tolerances are greater there. So if you're saying this, I had 2 shots and I'm saying this face was 2 degrees open in the path and this face was even, square, 1 degree open in the path, there's every chance that those two could have been exactly the same. So it'll give you a great idea, but when it's not being measured and it's being back calculated and it's back calculated off something that it doesn't know, there's room for there's a margin of error there. Yeah.
I would say when you're hands-on from a practical standpoint, if you're working with a golfer, and this is going to be obviously a lot of you guys, but you're always trying to constrain the variables so that you can give the right diagnosis. So if you're working with TrackMan, TrackMan's awesome, but it's nice to have some face tape too, because then you know exactly where they hit it and it helps you interpret the data more effectively. If you have someone that's hooking it because he's hitting it on the toe and you don't know that and you're telling them to close the face more, it's going to be a long afternoon. If you can look at each of those variables individually, you can fix the guy almost immediately. You just have to be on top of this stuff and be able to measure it properly and look at each variable and how it affects the other.
And one of the key things, again, is the head is super, super hard to measure. So if when you're looking at a measurement system, the ball measurements are going to be more robust almost across the measurement system, regardless of the measurement system you use. Head measurements can vary greatly because the head is super hard to measure. Impact location, the most critical thing. This, again, you have to use face tape. It's the biggest factor by far in ball speed, launch angle, and spin. Remember again, the MOI and what we call the IYY or the loft inertia in this plane is lower than it is in this plane. So any hit up and down the face, the margin is smaller. The degree of increments in loss of ball speed, launch angle, and spin are going to be greater. So across the face, like Nick said, if it's hitting on the toe, it's important to know that because you can move the CG, there's things you can do. The magnitude's not going to be as great across the face, so you have to pay significant attention up and down the face to where somebody's impacting the ball. Same as we talked earlier, the loft range can be 8 degrees, again, up and down the face, so you want to pay super close attention to that. What do you want to say?
Well, I would say, especially club fitting, look at things in the right order. If you don't know what's happening with the vertical hit location and you're seeing the spins go up and down, then don't start chasing that number with shaft when he's going to continue to hit it up and down the face, because you're going to go around in a circle. You're going to try 18 different shafts and not be able to get the number. You're going to be just chasing your tail. If you can constrain hit location and you can try some different things. And I would say, try the loft first. If you're 10.5 and you're trying to bring the spin down, go to 9.5. It's easier. You get an automatic 300. You don't have to worry about what the shaft's going to do. Ultimately, shaft's important, but use that further down the line after you've looked at the other variables.
Yeah, the collision between the head and the ball, the mass properties of the head and the ball, that's what drives the flight of the ball. So the shaft can change how the club's delivered, but the mass properties of the head, the ball, that impact, that's what drives the flight.
You know where the center is?
The center of the face?
Yeah.
Well, you can, if you look at, you can.
CGs are changing. Sometimes it's on the heel, sometimes the toe.
Yeah, well, if you have an adjustable CG, you can do that. If you don't, you should, online, you can find most of the information. Like most clubs that are made, it's like a game improvement type club, the center of gravity is more in the heel because they're trying to get some draw in there. So, but most a club, the sales rep usually can help you out with that too.
Yeah.
This is, if you're using your face tape in the center, it might not actually be the center.
Yeah, if they're hitting in the center and yours in face take, you're doing fine. They're not going to be doing too bad because even the increments of movement are so small that there's not going to be a huge variance in flight if they're hitting in the center.
I would say I wouldn't say it's crude, but it's not super precise. With the detachable heads now, you could just basically go like this and find the balance point. That's going to give you plus or minus a millimeter or so of where that balance point is, where the CG is. And then you can look at hit location in comparison to that, and then you start to figure out the side spins better.
How much do y'all factor in path to where the ball's getting hit in the face?
Get right there, you're at. You guys are smart. This is a sharp group. Club path, so that's the horizontal direction the club is moving relative to the target line through impact. And we definitely look at that. Typically, the more the club's coming from the inside, or the longer, if the shaft's too long, you're going to impact more in the heel. That's fairly common. It's not universal, but it's a rule of thumb. The opposite in the other direction. I would say, for sure, without a doubt, Annika Sorenstam, Colin Montgomery, Jim Furyk, Johnny Miller, Bruce Fleischer, who's an incredibly straight hitter. The straightest hitters we've ever worked with, and others that we've worked with that haven't been on our staff, so I won't mention their name, but have the most neutral path into the ball. Without question, the straightest hitters have the most neutral path into the ball. Not only do they hit the ball the straightest, they also have the least dispersion, so they don't hit any foul balls. You'll see somebody 3 or 4 degrees from the inside, a couple degrees from the outside. They'll have curve to the shot, and their mishits will be much broader. But I mean, you could put Annika and Johnny Miller and Colin Montgomery out there all day long, and their worst shot is not far from their best shot. It's incredible. Another thing about Annika that people don't realize, that I know you mentioned Lexi Thompson earlier. Lexi Thompson plays our ball, and she's been to the test center several times. Michelle Wee's been to our test center a couple times, and they're both around on our system 148 to 150 in ball speed. Annika was about 150, 151 in ball speed too. People underestimate Annika in terms of distance. She was not only the straightest hitter when she played, she was by far the longest hitter on the LPGA. So one of the reasons she dominated among several was that she hit it straighter than everybody and 30 or 40 yards by everybody. So. Quick thing about path, again, talking about measurement systems. You're measuring an arc. A path is on an arc, right? So where you measure can have a significant effect on the reading that the path has. So if I'm measuring at the ball versus 6 inches before the ball, obviously the one 6 inches before the ball is going to give me a more in-to-out reading. So I could hit 2 swings. I could have a guy hit 2 shots on different measurement systems that are exact same swing. One might say the path was neutral. One might say the path was 4 degrees from the inside. It might be the same swing. They're measuring at different points. So I know it's not encouraging. There's a lot of stuff going on there that it's hard to allow for. Yes?
It might be a little for Brian also. Brian, when you see gear systems, ENSO, TrackMan, the different measurements, same thing you guys see, do you think that what you're doing, Brian, is moving us towards more of a standard? Manzella?
No, I'm listening.
We've seen there's different areas for measurement, so if TrackMan catches angles,
Well,
attacks,
so the one thing like the optical systems like Gears and Enzo, they're trying to give you, even at 720 hertz, which is like frames a second, think of it that way, it's not catching first touch. So it's guessing more or less first touch. And then so it's trying to report first touch. At impact, Randy's shot at first touch was square. TrackMan and Flight Scope are trying to give you sort of a mid-impact number. So it's kind of apples and watermelons right now anyway, but it would be nice if everybody sort of went to one thing.
And the incentives are different. So if you're a TrackMan and you're selling a system that you want people to use to fit and coach with, the fidelity of that doesn't need to be the same as it does if you're doing what we're doing in R&D, where you're moving the CG 10,000ths of an inch. So when we get numbers, sometimes they're not the same as what somebody else would get. Doesn't mean ours are it's just different. They're just different systems.
We're all trying to get on the same page. on it.
Yeah.
We have the TrackMan people in all the time, and they talk with our engineers, and our engineers say, we run some independent tests. These are the issues we have with these numbers. And the TrackMan goes, well, this is how we got that number, and we're working on
They've
that number.
actually changed numbers based on input from us. The measurement system that we have, the USGA and the RNA both purchased our measurement system to use in their testing. So it's a.
So what kind of a change in angle would you be comfortable telling us that occurs during the initial contact with the ball leaving the club?
Oh, during that, not much. But the point is you can get so wound up in an absolute number to a degree or 1 or 2 degrees where the fidelity of the system's not capable of discerning that. So the thing you want to look for is more of a delta than the absolute number. So if you're using one system, right, and one time the guy's 4 degrees from the inside, the next time he's 9 degrees from the inside, well then you got an issue. There's a huge delta there. But if it's 4 degrees all the time on one system and 1 degree on another system, that can be the measurement error in the two systems. That's the difference. What you're measuring there is you're measuring the difference in how the systems measure. You're not measuring the swing anymore. So.
And I was actually trying to get to another point, which is with the fidelity of the machines that you use to do what your business is in, what kind of change do you think is occurring during the impact time of the ball?
How much is it closing during?
Yeah.
It's closing or the angle?
I'm trying to pick a direction. I don't wanna get
Yeah,
into-
you're assuming trying to constrain hit location on the face and all that kind of
Yeah,
stuff.
right. In other words, if you don't know any of that, what kind of a variation can you feel is occurring?
You'd have to ask people at our company way smarter than us combined. But I'll give you my card. You send me an email, and if I can give you that answer, I'll find that answer for you.
Absolutely.
Yeah.
Yeah, and I would.
We're just broken down range pros up here.
Tolerance of any system anybody can afford to buy. If that's the case, then we're gonna stop worrying about it.
Yeah,
And there are
I would venture to say there's not anybody in our company working on that hard as an answer either.
A lot of it too is our systems and our engineers might have capabilities that they don't use based on what we've decided is going to help us design a golf club.
It's not.
Like it might be a cool pet project for an instructor, but it's like, well, we're not going to spend $235,000 on that to get that answer because that answer doesn't help us build a golf club more efficiently.
It's gonna come off the same way each time because the equipment is so repeated. The point is, why worry about how much it is if it's inside the tolerance of what you're measuring?
Yeah.
True.
Yeah. Talk to me afterwards.
I want
Yeah, we do.
pretty much.
Oh, we got to roll. Okay.
Okay.
We're pretty close, I think.
Attack angle. So, yeah, attack angle, the same kind of thing. You're measuring an arc. It can vary based on where you're measuring. Main points are it's gotten shallower over the years. So as people have started to hit up on the ball more, realize that they can launch it higher with less spin and gain distance. Colin Montgomery, who I worked with just a couple weeks ago, right before Newport, when we first signed him, he was about 6 degrees down on the ball. And when he came in last week or last month, he was still 6 degrees down on the ball. When we first signed Phil, he was 6 degrees down on our system, 6 degrees down and 6 degrees across the ball. And Phil's now about 1 or 2 degrees up on the ball and a little bit from the inside. So Phil actually gained about 25 yards of distance with no increase in head speed, just by the way he delivers the club. Where Monty's still the same, and we don't have enough time where I tell you Monty's story. But efficiency or smash factor. Colin Montgomery's a great guy, by the way. I don't know. I mean, he gets a bad rap in the media. There's no more generous, sincere, nice guy than Colin Montgomery. Very appreciative, just a great guy. Smash factor, efficiency. That's the ratio of ball speed over head speed. So essentially dictated by the USGA, the ball can leave the face at about 1.5 times what the head speed was based on a 0.83 COR. So if the head speed's 100 miles an hour, the ball can leave at 150 or 150. The thing to remember with efficiency, if you use it, is it's not measuring how good a shot you hit. All it's measuring is how close to the alignment the CG of the head and the CG of the ball are. It's just measuring the transfer of energy. So you can have the face dead close. In fact, usually when you have the face closed, you have a less oblique impact and the efficiency goes up. You can get the ball out of bounds 400 yards and have a 150. So don't use efficiency to rate whether it's a good shot or not. You can see whether it's a good shot or not. Efficiency is just telling you, are those CGs aligned? That's all it's telling you. It's always going to be harder to get a higher efficiency with a lower club because of the oblique impact. When you get an oblique impact, more energy is lost to spin. It's not translated as much into ball speed. And Nick's favorite topic, compression.
Yeah, please.
Yeah, I won't spend too much time there because Brian did a great explanation of it in his presentation. I would say very quickly that compression or deforming the ball or squishing the ball, that is incidental to the shot you're trying to produce, not a goal. That's all I'll leave you with that. You guys can probably figure that out.
Which means more compression is not necessarily better. There's no reason to try and compress your 8-iron more than you would if you're going to hit it 150 yards to try and compress it more. If you want to do that, you can just bend the loft stronger and that would compress it more because you're creating less of an oblique impact. So compression is not the goal. Ball speed, critical to understand. Ball speed is much more important than head speed. Ball speed takes into account impact location. Head speed does not. So you can see, we see ball speeds all the time. I worked with a guy last week, 115 mile an hour swing speed. His ball speed could go from 170 to 162 based on where he's hitting it. His head speed stays at 115. So ball speed, launch angle, backspin. 3 critical factors to distance. That's what you need to pay attention to. Ball speed, launch angle, and spin rate. Also remember, ball speed is much easier to measure than head speed. The ball's always going to be easier to measure regardless, even on our systems. The ball speed's easier to measure than the head speed.
PGA Tour average ball speed and LPGA Tour average ball speed?
Right now, the PGA Tour, I haven't looked at TrackMan lately, I think it's around 166. LPGA is probably 139, 140. It's Lydia Coe, who just won yesterday, who's one of our staffers. She's like 143, and she's a little bit above average on the LPGA. She's way above average in playing, but she's a little bit average. She just turned 17. But again, you see these big drops in ball speed based on impact location. MOI has a huge effect on that, and low CG drivers. Low CG drivers, remember, have a lower MOI. So when you're lowering that CG, there's more room above that CG to hit. You create a bigger offset vertically. You get a faster degradation in ball speed. You can get a worse spin condition and a worse launch condition real fast. So you have to be careful where you're hitting vertically, and also, as I said 10 times, the MOI this way, the loft inertia is lower, so it's more sensitive to change. Launch angle, measuring degrees relative to the ground, everybody knows that. Launch angle is a bigger factor. Can be helpful as a bigger factor at lower speeds than spin when you're fitting or teaching. So if you've got somebody that's kind of in the medium to low end, you can't always get somebody in the right launch and spin. So if they've got a slower speed, you want to focus more on launch angle, getting them with LPGA players, we're usually trying to get their launch in the 12 to 13 to 14 range. High speed guys like a Gary Woodland, we're not so concerned about his launch, we're more concerned about spin. Bottom note, Phil literally used to launch the ball at 6 when we signed him. He launched the ball at 6 with 33 to 3,500 RPM to spin. So it would be almost impossible to be less efficient than he was. Side angle is the direction the ball starts relative to the target. Brian mentioned it earlier. The club, in our research, the club's responsible for about 75% of where the ball starts. MOI and bulge will obviously play a role in that. The tighter the bulge, the more bulge you have, the farther offline it'll start. Same with the MOI. Spin rate.
Brian, you said something at the beginning, you were saying that the numbers were changing on that?
We're sort of hearing, maybe lower than that with a driver. I don't know if that's just, it's hard. It's a really hard test to do. That's the way Paul Wood said. It's a really hard test to do.
Are you guys finding that as well?
Well, yeah, not exactly. You have to look. Also, we're fitting guys. We're trying to make golf clubs and setups so guys can go play golf with them, right? So you can set up the ball launching machine and you can raise the launch angle and continue to change the spin rates. And at some point, you get some. It looks like this, and it goes over knuckles a lot, and maybe under certain conditions, that one carries a little bit further, but maybe it doesn't roll as far because the terminal angle's down. You can look at a bunch of different things, but then you go, can a pro go out and go positive 8 degrees with his attack angle with a 4-degree lofted club and play golf? So you run into those constraints, and you figure out, what does a guy like to look at visually, and within those ranges, what's a really efficient way to go about it? And so, for us, personally, 17 degrees to 1700 is not really a very playable shot. Especially when you drop the spin rate, it becomes that low. It just.
He's asking about that.
75%. 75%.
Oh, okay.
Sorry about that.
Your 75% was driver, right?
Yeah.
That was a driver.
I was
So that's lower
asking
than
you guys to see
85.
the difference.
Right, and that's what you said. It's trending.
It's trending now.
That's what our research is. So, Yeah, so what Brian's saying is consistent with what we're saying. He's at 85, and they see it, his group, or his research, he's been spending time, sees it trending low. We're like 75 to 77% in the research that we've done with the driver. Spin rate, measured in RPMs, determined by dynamic loft, impact location, head speed, attack angle. More critical, like I was just saying, at high speed. Right now, we typically with our players, we fit them into spin about 23 to 2800. So whenever we're working with a tour player, the first thing we do with the driver is ask them when they hit a shot, just say, that's what I want my ball to look like. We don't ever try to fit them into what we think they should have. We'll have them hit, and then they say, I want it to look like that, and make a note of what that launch and spin is, and then we're in that range. If it's way out of a range, then we would show them what the trade-off is. We'd say that potentially this is what you're losing based on what you're doing.
So if you had that player that said, that's the shape I like, and the the spin was a little too high, and the launch was off, would you then try to jockey that spin and launch to then line up with what suited his attack?
Yeah, you can, but you're limited by the parameters of the head unless you start changing their swing. So like when we first started working with Phil, he was launching at 16, he was at 3,500. So we could mitigate some of that with our equipment. And so we would show them, we have a bunch of software programs where you can put in all kinds of parameters. You put in barometric pressure, temperature, impact location to the millimeter, everything. And then it'll show you what the flight would be. So we could show him that. He said, well, yeah, I want that. Yeah, who doesn't? But you're limited by the input, which is how he delivers the club. So we'd already maxed out what we could do. So if you could get him 8 yards of that 28 by the equipment, the other 20's got to come by changing his attack angle, which is what he did.
The player said, this is what I like to see, and you just see that the numbers are kind of garbage. You want to leave him with as much gain as possible.
Right.
You're going to try to work that without him knowing what
Always.
to do.
Yeah, and like I said, you're going to be more limited typically in the equipment than you are in the delivery of the club. So you just explain that to him. Like I explained it to Colin Montgomery. Colin, if you want to hit down 6 degrees, this is the match you're going to get. If we change that, you could do this. And again, we don't have time for that story. Previous balls were, do we have time?
Yeah, tell them mine, sir.
So this is like 2006, and Colin Montgomery had been, he won the Order of Merit, whatever, 8 years in a row, or 8 out of 9 years or something. He dominated Europe. He'd always been in the top 10 in driving distance. He averaged like 277. So at the end of November, the end of the year in November in 2006, he called. He was coming here to play in the Tiger event. And now he's averaging 277 again, and he's like 60th in driving distance. Well, 2006 was about the time when everybody started hitting up on it, launching and higher, everybody but Monty. So he called and said, I want to, what's going on? So he flies over, he comes to the test center the Monday of the tournament at Sherwood, the Tiger Shootout. So we go up in the conference room, we put in all his coordinates, we show him what he's doing, we show him what the potential is, and it was like 27 yards or whatever it is. He says, yeah, I want to do that. So Monty and I go down to the range, it's him and I for the whole afternoon. And we explained to him, look, we're maxed out at the club, so you're going to have to change the way you deliver the club. So we go down the range, change his ball position, change his tee heights, change his setup, change things to his swing, and he was awesome. Just full in on everything, let's do it. We have our measurement systems out. We're looking at the launch go up, we're looking at the spin go down. Head speed was pretty constant, but the carry was farther, the roll was farther. It literally was hitting 20 to 25 yards farther. He's just super excited. So he leaves Monday night, drives to Sherwood. Sherwood has, at Tigers Tournament, they have a Pro-Am Tuesday and Wednesday. So he plays the Tuesday Pro-Am, relaxed, plays great, calls and said, I can't believe it, I hit 25 yards farther. This is incredible. Plays the Wednesday Pro-Am, same thing, calls, this is phenomenal, hitting 25 yards farther. Plays Thursday. First hole at Sherwood's a little dog leg left, you tee off with a 2-iron, so he hits a 2-iron and a wedge, makes par. Second hole's a par 5, aims down the left side to hit a cut and pull hooks it against the fence. So he calls that night and goes, can't do it, I'm done. And it took him 2 holes. And the beautiful thing was, he knew that he couldn't play golf like that. So in space, the club had changed to him. He no longer had a feel where the path was or where the face was in space. And so he said, I might be able to hit it 25 yards farther that way, playing recreational golf, but in a tournament, I can't do that. So the neat thing is you have, everybody knows the names. There's 100 guys who have tried to change their swing and would have pull hooked that against the fence and stayed on that road for 3 years until they're into oblivion. And Colin Montgomery knew after 2 holes in a tournament This is something I'm not going to be able to do. I'm just going to live with hitting it like this. So when he was here last month, he came in as soon as I saw him. I go, "You here to get that 25 back?" And he just started laughing. He said, good, right where I am. Spin rates have dropped dramatically from the old wound ball to the new ball. They used to be designed to perform optimally about 3,300. Now they're designed to perform optimally about 2,300, which is why they do go longer and why they do go straighter. We've done tests where we did a test about 10 years ago with a wooden driver and a wound ball, titanium driver, and a new ball. And we crisscrossed them. So we take the new driver with an old ball and the old ball with a new driver. There's about a 25-yard gain for the ball and the driver. So there's about a 50-yard gain total. So that was at tour head speed. So if you took a wooden driver and a Bellotta ball, it would go 50 yards shorter than a new titanium ball and a new driver.
Okay, Randy?
So they do go longer and straighter.
Given that information, do you have anything going back in time with all your data that really showed how long Jack and other guys of his era really were playing that ball and that equipment?
There's some old like ancillary data. We don't. We as soon as we signed on with Palmer, we took data off him, but he was way past his prime. So we don't have anything like that. Not that I'm aware of. Do you know, Nick?
No, but I mean, you talk to some of the guys, you make some guesstimations, and what Jack and Arnie were putting on with those clubs and trying to make those balls go as far as they did, it must have been creating incredible amounts of club head speed. I mean, or 120s, 120 something.
They did something on Bobby Jones. It was 113, and he was never known to super.
I know when Phil won the PGA in 2005 at Baltusrol, they got rained out. Maybe I had to finish the last hole the last day. He had a forward into the green, which was a new forward with a new ball, and he walked about 3 steps to tap the plaque where Nicklaus had a 1-iron onto the green in 1980. So I don't think Phil could have got a 1-iron onto the green with a new ball at that point. No matter how many times you hear it on TV that the shot came out with overspin, it never comes out with overspin. The ball won't fly with overspin. You need lift to make the ball fly. You need backspin to create lift. Side spin doesn't exist actually. Side spin is just defined so you can understand the magnitude of curvature, but there is no such thing as side spin. The ball always spins around the spin axis of the ball. And you can't hook or slice a putt. You hear people talk about that sometimes, especially in pro-ams. They go, "I don't watch this guy putt because he hooks his putts or slices his putt." You can tilt the spin axis of the ball, but once friction takes over, once the ball starts rolling, the ball always rolls end over end. There's no such thing as hooking or slicing the ball. This is what true spin looks like. So you've got this axis, and for the ball to curve, you have to tilt that axis. It's no different than a plane. So if you tilt the plane, if you tilt the wings, it curves. So backspin is the vertical component of true spin, and side spin is the horizontal component. So when I tilt that axis, I get a side spin and I get a backspin. But the ball's always spinning around its true spin, always spinning around the spin axis.
Does it start out with true spin and then tilt at speed, or it immediately starts that?
As soon as an oblique impact, the vector just tilts. These are contour plots. These next two, they're a little bit busy, but basically the point is, again, on launch and spin, this is at 180 ball speed, so this would be like a Gary Woodland type speed. So when you look on a contour plot like this, you've got launch angle on the vertical axis, backspin on the horizontal axis, and essentially what it's showing you when the lines are more up and down like that is that this is more sensitive to spin for distance, and this would be, you see how the lines get more horizontal. This would be more sensitive to launch angle for distance. So again, if you're working with somebody, high head speeds, if you can't get them in the right range of spin and loft or launch, you want to pay more attention to spin. Low head speeds, medium to low head speeds, launch angle is more critical to the overall distance. So that's all we have for you. We appreciate your time. I know there's a lot of variables going on, and the main point is the more you understand about the variables, how they interact, how they work together, the more effective you can be in boat teaching and in boat fitting.